All right, so let's get right into it. Think about this. We've spent all this time talking about how to build a computer, right? We've given it a brain, the CPU, a heart, the motherboard, memory, a whole nervous system. We've basically created this incredibly powerful mind. But there's a catch. It's a mind trapped inside a metal box.
And that brings up a really big question, doesn't it? How does this mind, this thing in a box, actually know what we're thinking? And maybe more importantly, how does it show us what it's thinking? How do we actually have a conversation with it?
Because that's really what we're dealing with. A mind without any senses to perceive the world or any way to express itself, well, it's a prisoner. It's stuck. So today, that's what we're going to do. We're going to set that mind free. We're giving it senses and we're giving it a voice. And we do that with what we call input and output devices.
Okay, so first things first. Let's give our computer some senses. This is where input devices come in. You can think of them as the tools that let us get our thoughts, our commands, all that stuff from our physical world into the computer's digital world. It's literally how we talk to the machine.
And the most basic, fundamental bridge we have is the keyboard. It's pretty amazing when you think about it. It takes our language, letters and numbers, and translates it into the only thing a computer actually gets, code. Every single time you press a key, bam, it sends a unique little signal, a scan code, that the computer knows exactly what to do with. It's how our typed out thoughts become commands the machine can actually follow.
Then there's the mouse. Wow, did this thing change the game? The mouse is what really brought us the whole world of graphical interfaces, icons and windows. We went from having to type every single command to just pointing and clicking on stuff. It feels so natural to us now, but man, it was a total revolution. It's the sign language that made computers friendly for, well, pretty much everyone.
Now, what about hearing? For that, the computer needs ears, and that's the microphone. And what a microphone does is it's kind of magic. It takes the sound waves from your voice, which are smooth and analog, and it chops them up. It takes thousands of tiny digital snapshots every single second, turning that continuous sound into a bunch of ones and zeros that the computer can finally understand. And of course, for sight, the computer needs eyes. That's where webcams and scanners come into play. They take in light from the real world and focus it onto a little sensor grid. And that grid, almost instantly, creates a digital map of pixels. Each tiny dot has its own color and brightness, translating our physical world into a picture the machine can actually see.
All right, so we've given our computer senses. It can feel our touch through the keyboard, see our world with a camera, and hear our voice with a mic. But, a conversation is a two-way street, right? It's not enough for us to just talk at it. We need the computer to talk back, and that's where output devices come into the picture.
The monitor, this is probably the most important one. It's the face of the machine. It's the canvas where all those invisible, abstract calculations happening inside the box become something we can actually see. The graphics card and the monitor work hand in hand, translating millions of ones and zeros into a vibrant grid of pixels. It's how we get text, images, video, our entire visual world on the computer.
So, if the monitor is the computer's face, then speakers and headphones? Well, that's its voice. They do the exact opposite of a microphone. It's like reverse magic. They take digital data, those ones and zeros, and use it to vibrate a tiny cone or diaphragm, perfectly recreating the sound waves that we hear as music or voices or sound effects.
And then, sometimes you need something you can actually hold in your hands. That's the printer's job. It's like the computer's writing hand. It takes a purely digital thing, a photo, a document, and boom, it lays it out on paper, creating a physical copy. It's that final step, bridging the gap from the digital world all the way back to our physical.
So, okay, we've got all these senses and all these ways for the computer to express itself. But how do they actually connect? How do we plug these things into the computer's brain? Well, it pretty much boils down to two choices. You either use a cable, or you cut the cord and go wireless.
And really, it's a classic trade-off, isn't it? Stability versus freedom. You go with a wired connection, like a USB cable, and you get a rock-solid link. There's no delay, which is absolutely crucial if you're a serious gamer, and you never have to worry about batteries dying. The downside? Cables. Everywhere. On the other hand, you go wireless with Bluetooth or Wi-Fi, and you get this beautiful, clean desk and total freedom to move around. But you've got to keep things charged, and there can be a tiny little bit of lag. At the end of the day, it just comes down to what you care about more.
So,
Let's pull back for a second. What happens when we put all of this together? When you have the senses, the input, and the voice, the output, all working together in harmony. Well, you get something pretty remarkable.
See, these input and output devices, they aren't just little accessories you plug in. No way. They are the bridge. They connect our physical world to that digital world inside the machine. It's this constant conversation, this back and forth, data flowing in and responses coming out that makes everything we do on a computer possible. From just sending a quick email to designing a whole skyscraper. This is how that mind in the box is finally set free.
So we've built the body. We've figured out how it communicates. But that leaves us with one last, and I think, really fascinating question. When you reach over and you press that power button and that machine hums to life, what is the very first thought that goes through the computer's mind? What's its first instinct? Well, we're going to dig into that in our next explainer.